the Chief Operating Officer here at Gulf of Maine Research Institute, and it's my real pleasure to welcome you to our Joan Kelly Sea State Lecture. And have just a couple of little housekeeping things for those of you who need it. There's a bathroom outside of the Cohen Center down the hall to the right. We also ask that you not bring food and water or food and beverage here for the sake of the many thousands of kids that come in after you. So, want to do a quick show of hands. Who has never been to a Sea State lecture before tonight? All right, lots of you. Great. Well, welcome to you, and welcome to all the rest of you who are returning here. We love to see our repeat participants. Want to make a special shout out to this Colby crowd here, being my alma mater, and to Nick Record from Bigelow Lab. But really do want to welcome all of you. And for those of you who don't know us, the Gulf of Maine Research Institute pioneers collaborative solutions to global ocean challenges. We have a new strategic plan, and that's our new mission statement. And what does that mean? Well, it means that we are first and foremost committed to the Gulf of Maine bioregion, the incredible marine bioregion that it is, and learning as much as we can about it through our research, education, and community engagement. But the problems that we are trying to understand here and the solutions that we're trying to develop here really do pertain to oceans all over the globe and really have relevance, part of which Andy will talk about this evening. We invite you to learn more about GMRI. There's plenty of materials that you can find after the lecture. So, this lecture series is sponsored by the Joan Kelly Charitable Trust, and we thank them for their support, as well as FishVet. And we're particularly excited about this series, the Debunking Myths. Pretty much almost all of the lectures on this one are from our staff. And the way we decide on these topics is very much a collaboration with our staff. And there was just this sort of repeated thing, people think this when actually it's that, and et cetera. So this is a part of a series. We hope you'll come back to the next several. And now it is my pleasure to introduce Andy Pershing. Andy Pershing is our Chief Scientific Officer here at GMRI. He became that role 3.5 years ago, but had actually been part of our lab for many years before that as part of a joint appointment with the Maine School of Marine Sciences and as a research scientist here at GMRI. He also runs our ecosystem modeling lab and has really been at the forefront of a lot of climate-related change research happening in the Gulf of Maine. And tonight, he will be speaking on climate myths and legends. Andy Pershing.
All right. Thanks, Ellen. Welcome, everybody. So as Ellen said, this is a series about debunking myths. So what bigger myth is there than the myth of climate change, or rather the myths that climate change isn't real? And so that's what I'm going to try to talk through tonight. So I'm going to start with a myth.
The story of Oedipus, as told by Steph and Amanda.
Not what you were expecting, right?
Once upon a time in Thebes, there was a king named Laius and a queen named Jocasta, and their little baby son, Oedipus. King Laius had heard a prophecy that little baby Oedipus would one day grow up to kill him and marry Jocasta, neither of which he was eager to have happen. So he did the most reasonable and totally not at all awful thing he could think of. He left his baby to die on the side of a mountain. Good news, though, someone found him and took him to Corinth, where he was adopted by King Polybus and Queen Merope. Being adopted by a king and queen is the ultimate dream of orphans everywhere, so this would have been a super sweet deal for Oedipus, if it weren't for everything that happened after. One day, when he was grown, the Oracle of Delphi told him all about that pesky prophecy that said he would murder his father and marry his mother, but apparently it neglected to mention that it didn't mean Polybus and Merope, just one of those wacky miscommunications, you know? So, obviously, Oedipus decided he had to get out of Dodge, or, Corinth. Whatever. He headed for Thebes, but along the way he met an old man and got into a fight, which obviously ended with Oedipus killing him, because what other way could there possibly be to settle an argument with a stranger? Spoiler alert, the old dude was Laius, and Oedipus just fulfilled the first part of the prophecy, though he doesn't know it yet. Life's just funny that way sometimes.
Huh? Okay, so, so first of all, thanks to Steph and Amanda. I have absolutely no idea who they are. I assume that was a student project. You can't find anything about them on the internet, but that I think is it was the best thing I could find that's a telling of the Oedipus story. So, what's going on in that story and how does it relate to climate change? Well, what's going on in the story? There are two kinds of characters, or two archetypes. There's the oracle and there's the hero. So in that story, the oracle is the oracle at Delphi, otherwise known as Pythia, who is a priestess who lived in a cave and made proclamations to mortals about their fate. The heroes in this story were Laius and Oedipus. And hero, I'm going to be using as more of the protagonist, not necessarily somebody who's heroic, who you want to be behind. They could in some ways be the anti-hero. But they're going to be the main character in the story that I'm telling tonight. Then, what happened? Well, the oracle issued a prophecy, in this case based on divine knowledge. So Pythia is sitting there in her mythical cave. She's sitting on a tripod. She is inhaling these vapors coming out of the mountain that allows her to tap into the mythical power of Apollo and to see into the future. She sees the future for Laius and Oedipus. She neglects to kind of give them all of the details. And they get that information and they have to act on it. Now you can think about whether the Greeks actually believed that Laius and Oedipus had a choice in all of this, but that's for the Greeks to debate. But what I want to point out is that this conflict between these two archetypes, between the oracle and the hero, this is something that appears throughout literature. You can go before the Greeks. You have the Greeks. There's lots of Western literature. And then now it's even part of the mythology that we're developing around movies. And so I'm going to work some of that in the story tonight. But this does connect to climate change. And it connects because I think one of the challenges about getting action on climate change, specifically getting action around curtailing carbon emissions, falls into this trap of the archetypes between an oracle and a hero. So in this case, the oracle are the climate scientists, and the hero is us, people like us who are making decisions out there in the world. Instead of inhaling vapors, scientists are looking at math and data and putting the story together and making projections about the future based on that understanding, based on the data, although I will admit to inhaling some dry erase marker fumes from time to time. But then the heroes, meaning us, have to make choices based on those pronouncements. And that, as I'm sure most of you are aware of, has been a challenge, especially here in the United States. So let's start by first trying to understand a little bit what the scientific prophecy is in this case. So I'm going to start with coal, with, of course, clean, beautiful coal. Specifically, the energy that we get from it when we burn it. It produces carbon dioxide that goes into the atmosphere. Okay, so we've had rising levels of carbon dioxide in the atmosphere. Carbon dioxide is a greenhouse gas, which means that it retains heat. So as the heat tries to radiate from the planet, CO2 in the atmosphere absorbs it and re-radiates some of that heat back to the surface. So it's like adding a layer, it's like adding a blanket around the planet that keeps us warmer. Then that warming, of course, increases the temperature of the planet, but the warming also activates other features of the climate system. And this is really important. It isn't just CO2. The climate system of our planet is really complicated, and CO2 is just the trigger in this case. So CO2 triggers a little bit of warming that then gets amplified by all of these other processes, by declines in ice in the Arctic, which reduces the amount of light that gets reflected back into space, so it leads to some additional warming. It does things like increases the amount of water vapor in the atmosphere. Water vapor is also a potent greenhouse gas, so that gives you even more warming. Then we get a change in climate. And by a change in climate, what we're talking about is a change in the average conditions on the planet. So you can think of that, and most of the time when I'm going to talk about this, it will be the average temperature of the entire Earth system. But you could think of it as also being the average conditions at any given place on the planet. So not the weather that you're experiencing at that moment, but how likely are you to get the particular weather that you're experiencing in the moment. So we are much more likely to have an extended, say, month-long warm period like we've experienced this fall in a warmer climate than we would have without extra CO2 in the atmosphere. So we're used to thinking of climate change as a really new thing because we as a society haven't really been talking about it for a long time. We kind of think that Al Gore invented it right after he invented the internet. But it actually goes way back. So the theory and the data and the scientific story of climate change, you can take it all the way back to the late 1800s. But I like to start in 1965 because that was the first time that a group of scientists briefed the President of the United States, who was President Johnson at the time, about the potential threat that rising carbon dioxide in the atmosphere poses. So from their briefing, they said that almost certainly rising levels of carbon dioxide would almost certainly cause significant changes in the temperature and other properties of the stratosphere, and that these changes could be deleterious from the point of view of human beings. Okay? So they were able to say, we've seen CO2, Keeling had started making really detailed measurements, so they had really good data. They were looking at ice cores and other kinds of geologic evidence to be able to put together the connection between carbon dioxide and the temperature of the planet. So the mechanisms were there, but they couldn't quite quantify it. So they could say that we know the direction of the change, and we know that that could be harmful, but they couldn't say precisely what level of change society is really facing. So fast forward now to 1981. James Hansen has a paper in Science that uses one of the first climate models. And so he's one of the first people to really try to grapple with the complexity of the climate system and what happens as you add CO2 into the climate system. So in his, and this is one of the earliest climate projections, he said that anthropogenic carbon dioxide warming should emerge from the noise level of natural climate variability by the end of the century, meaning the end of the 20th century, not the end of the 21st century. Okay? Which is great because we here at the beginning of the 21st century can actually check whether James was right. He also said that it would lead to the creation of drought-prone regions in North America and Central Asia, although he wasn't precise about when that would happen, and that we would see at some point in the future the opening of the fabled Northwest Passage. So let's see if Hansen was right. So this was the data that Hansen had at the time, and in fact his group was one of the first to really start to assemble global surface temperatures and come up with kind of an integrated picture of what the average temperature of the planet was. So you can see that in 1981 it was in fact a record warm year, but not very much warmer than 1945, which was the previous record, and this interesting kind of warming that they had in the 1940s. So based on what he had there, he couldn't, it's not like he was fitting a line and just saying, oh yeah, this is going to keep going. He really was looking at the data, he was looking at the mechanisms, he was bringing in the theory and making a projection based on that understanding. So fast forward to 1988, you're starting to see a little bit of warming. In 1988, Hansen had a couple more papers. He was also called in front of Congress, in front of a Senate committee, and he testified that the greenhouse effect has been detected and it's changing our climate now. We already reached the point where the greenhouse effect is important. Okay? And people here in the 2000s have credited that testimony with really starting the national conversation around climate policy. So, continue the time series. Now, here we are at the end of the 20th century, and I hope you can see that there's a very clear trend in that data. And of course, that trend has continued. 2016 was the warmest year ever on our planet, at least in terms of anything we're able to measure as humans. 2017 is going to be just slightly below 2016, and that's because 2016 was an El Nino year, which tends to give just an extra kick to everything on the planet. But what about his other projections? So he projected drought and ice. So we are now tracking a resumption of the drought in the Southwest. So we had 3 years of very intense drought in California. It was a lot in the news. The drought ended with really torrential rains and snows this spring. But the drought is now back in the Southwest. And of course, there are the wildfires in Northern California that are also related to this climate story as well. Declines in sea ice every year. The ice level in the Arctic continues to decline. This year, I think, is the 4th lowest year in the Arctic. And the Northwest Passage is not only open, it's open for business. So there are cruise ships that are transiting, or there is a cruise ship that is now booking trips through the Northwest Passage. So we can now take the models, and these are the great-great-grandchildren of the models that James Hansen was running, and we can make more detailed projections about what the future could look like. And so this is really what the prophecy, and of course it's not vapors and caves, it's math and physics that are allowing us to make these projections. And what we see is that, well, we have a choice. If we continue to emit carbon dioxide from coal and oil and things like that, at an ever-increasing rate, we will end up with 4 degrees of Celsius warming by the end of the century. If we curtail our carbon emissions, and this is a pretty radical curtailment, basically it's kind of a cold turkey scenario, we stabilize our temperatures at a more modest level, right? It's something that looks more or less like what we have now. But it's not quite perfectly what we have now. You'll notice that these two curves overlap. And they overlap for about 20 or 30 years, and that is the time scale that it takes all of those climate feedbacks to come into play. So we here in 2017 are in equilibrium to the carbon dioxide that was emitted 30 years ago, okay, in the late 1980s when Hansen was first testifying in front of Congress. The carbon dioxide that we emitted this evening in all of the mechanisms that we got here and with all of the lights that we have on in this room is going to affect the climate now at the middle of the century. So the climate future is not written in the stars. We have a choice, but some of the cake is baked. Okay, enough with the aphorism. So, but what does this future look like? Okay, so in 2100, we are potentially looking at a very different world than we're facing right now. So this is a graph that shows on the left is the temperature in degrees Celsius. It's what's called the wet bulb temperature. So it takes into account temperature and humidity. The interesting thing about this graph is the red line at the top. The red line at the top is the temperature, the wet bulb temperature, where the combination of temperature and humidity is so severe that a human can't survive outside. Okay, we basically overheat. We can't. We try to sweat. The sweat doesn't evaporate, and so we can't keep our bodies cool. We are looking at, in the high CO2 emission scenario in places like Doha, Qatar, having conditions where humans can't survive outside. Okay? Think about what that means. That is a radical, radical change on the planet. This is an area that was the cradle of civilization 10,000 years ago. And all of a sudden, in less than 100 years, humans might not be able to live outside in that environment. But it's not just humans. Studies are showing that, that by the end of the century, that in a high CO2 world, that most of the coral reefs in the world will be bathed in water that is too acidic and too warm to support what we know as a coral reef ecosystem. So this is an ecosystem. This is an important, beautiful, productive, highly valuable ecosystem that exists all over the tropical regions of the planet that won't be there at the end of the century if carbon dioxide emissions aren't curtailed. We also are looking at cities, okay? So this is Miami. So you can see the normal outline of Miami Beach. And this is with the NOAA sea level rise simulator. What happens with 3 feet of sea level rise? The whole western side of Miami Beach goes away, right? It becomes part of the ocean. And 3 feet of sea level rise is at the low, it's at the low end of what we would get in the high CO2 scenario. Okay? So major, major changes on the planet if we go ahead with the high CO2 scenario path that we're on. Okay. Hurricanes, yeah. What could be more less depressing than hurricanes? Right, of course, warm water fuels hurricanes. If you have more warm water, you have the potential to make bigger and more powerful storms, as we saw this year. So, Now I want to talk about some climate myths. So my first climate myth is...
I imagine you might be rather cold.
Winter is coming.
And winter is coming.
Winter is coming.
Might just be the cold.
Yeah, it might just be the cold, right? So every time it snows, you get stories like these. So this was from snowstorms in 2010 and 2011. 2010, Fox News put An Inconvenient Truth, Al Gore's book about climate change, out in a snowbank. 2011, they sent their reporter on the street with with the banner, "What global warming?" Right? Because it snowed in Washington, D.C. Okay, this comes out all of the time, and actually, Nick Record has a blog post up on our blog where he's tried to sort of see, is there a seasonal cycle, or are there trends in how weather affects climate reporting? And it's kind of a neat analysis. But of course, what they're missing here, right? The reason they're getting this myth wrong, the reason that it's a myth in the sense of something that we say that just isn't true, is that the prediction that we have about global warming isn't that, well, it won't snow in Washington, D.C. It's just that it will be warmer on average in Washington, D.C. So let's look at the data. So this is the distribution of temperatures for any day in February during a period from 1960 to 1979. So a 20-year period, you just throw all the data together, you get a mean, you get a standard deviation. So you can look at how likely you are during that period to get a particular temperature. And this is the nighttime temperature, the minimum temperature during the day. So the mean during that period, the average temperature that you would expect in Washington, D.C. during the 1960s was 22 degrees Fahrenheit, and that 84% of the days during that 20-year period had a minimum temperature in February where it was cold enough to make snow. Okay, so what does it look like here in the most recent 20-year period? Well, the mean has shifted. It's warmed up. That happens just about everywhere you look on the planet that we have right now. In this case, by about 4.3 degrees Fahrenheit. But 74% of the days, still 3/4 of the time, your cold temperature your nighttime temperature in February is below freezing, so you could have a snowstorm. But the other thing that they didn't factor in, of course, in the Fox News stories, is that in a warmer climate, we have a lot of freezing days, but a warmer atmosphere means that you have more water vapor in the atmosphere. This is one of these really important climate feedbacks. So more water vapor in the atmosphere means you have potential for bigger rain events, and if the temperature is below 32 degrees Fahrenheit, you have bigger snow events. And that's a trend that we're starting to see very clearly here in the Northeast. So, myth number 2.
No, it wasn't me. It was the one-armed man.
All right, one of my favorite movies. So it wasn't, it's not CO2, it's something else, right? It was the one-armed man, or it was Jupiter, or it's sunspots, or it's natural variability. So natural variability meaning all of the things that happen on the planet that could cause the average temperature to change. One of the things that people point to is El Nino, and there was a lot of reporting about how in 2016, the record temperature that we had in 2016 was, oh, well, it's just because it was an El Nino year. During an El Nino year, you have really warm water, extra warm water along the equator in the eastern Pacific. Normally, this water is actually quite a bit cooler than you would expect based on it being at the equator. That's because you have cold water coming up from depth, and that's the Earth's air conditioner. During an El Nino year, warm water slides over, and that air conditioner turns off, and global mean temperatures go up, and you have changes in weather all over the globe. It's just an amazing, amazing phenomenon. So what I did was I pulled up 3 of the most recent, most powerful ENSOs, and then I looked at the change in temperature, and this is in degrees Celsius between... ENSO? Oh, sorry, ENSO, El Nino, the El Nino Southern Oscillation. Yeah, sorry, nerd speak. So, so I look at the change in temperature between the peak year and the year before. So in 1983 was 0.17 degrees Celsius warmer than 1982. 1998 was 0.16 degrees warmer than 1997. And 2016 was 0.12 degrees warmer than 2015. Okay, so those are pretty much the same number. but look at the baseline that you're comparing it to. So the baseline, the temperature in 1982 in these anomaly units, this is kind of a relative to a long-term average, was 0.13 degrees, 0.48 in 1998, 0.87 in 2016. And you can see those years on the graph. They show up as peaks, so 2016 was a peak above 2015. So the peak is El Nino, so El Nino lifts you up. But notice what happens. So in 1998, we take a jump, and then within about 2 years, that jump becomes the average temperature, right? So same thing happens in, so that was 1983, sorry, 1998, you take a jump, that becomes the average. 2016, you take a jump. Within a few years, that will be our average year. So, climate myth 3, this is my final climate myth.
We've seen this before.
Cool stuff, but we've seen it all before.
Yeah, I've seen it before.
Threw that in for you. So we've seen it all before, right? This is nothing. This is nothing new. Well, really, what people are saying is that yeah, it's nothing new. We've experienced this before. There's just variability in the climate system. It's no big deal. We don't have to worry about it. Well, it is actually a big deal. It is a significant change that we as a species are experiencing. So we as a species have lived through, and this is ice core data. This is the carbon dioxide levels. So this is where we're at the last IPCC, which is a little over 360 parts per million. This is where we are today, 407. This was the average during the last 10,000 years. This was the CO2 levels in the ice age. So it's about a 200 parts per million change in CO2, more or less a doubling in CO2 between here and here. We as a species have been on the planet for about 200,000 years. We've seen 3 of these cycles with equivalent changes in CO2. But think about what we as a species looked like before the last ice age. Well, we looked the same, but we didn't wear clothes. We didn't shave. We hunted our food. We gathered. We lived in small family groups. And at that point, we were restricted just to Africa and a little bit in Europe and Asia. And we really didn't start to begin to cover the globe until after this ice age. The other thing we didn't start to do was until 10,000 years ago, we didn't learn how to grow crops. We didn't learn how to live in large groups in things we call cities. We didn't learn how to have economies that are based on trading goods. All of the things that we think of as civilization evolved during this last 10,000 years, during this very, very quiet period in terms of carbon dioxide levels. So what we're doing is confronting our species with the change that, yes, we as a species have experienced it, but we haven't experienced it as we are now, right? And so it has the potential to be incredibly disruptive to us as a species, not to mention all of the other species on the planet, because that's the part per million that we would get through the Paris Agreement. Okay, this was the agreement that most of the countries signed on to. The U.S. unsigned it, kind of. And even with that, that is the first time that countries of the world have agreed to binding targets around carbon dioxide, we still are looking at a really significant increase in the carbon dioxide levels of the atmosphere. The business as usual case would be way, way off the chart. That would be the one that gives us 4 degrees of warming. So yes, we've seen it, but we as people who grow crops and live in cities have not seen it. So there are lots and lots of other climate myths. I don't think it would be a very interesting talk to go through all of the 195 ones that skepticalscience.com has put together, especially because they have really great descriptions and great answers. So, so Thanksgiving is coming up. Everybody has the crazy uncle. I would encourage you to, have this up maybe when he says something wacky at dinner and you can say, yes, but we'll see how that works. But the question I want to ask, though, is why are these myths so persuasive and pervasive, given that the science case is so strong? Well, of course, one of them is that there is dedicated overt resistance, organized resistance to the idea that carbon dioxide causes changes in the climate. So you have ExxonMobil got the email treatment where they were caught saying one thing in public, funding anti-climate science and another. Koch Industries doesn't really even bother to hide it. This is one of the products that has come out of this. This is the Why Scientists Disagree About Global Warming by the non-governmental panel on climate change, basically trying to spread climate myths. This got sent to a school teacher that I know. So this is out there in the world. So why are these myths so sticky? Well, I think in part, there are lots of other reasons, but I think that we can gain some understanding by thinking about this in terms of the heroes and oracles problem. So let's think about heroes and oracles with the first story that I want to tell. So I'm going to tell a hero and oracle story. I had a video, but I decided the video took too long. So I am going to reenact the scene with Macbeth and the Weird Sisters. So bubble, bubble, toil and trouble, all of that, right? So that's those are the Weird Sisters, the witches in Macbeth. Macbeth goes to visit them. This is the second time he's gone. The witches give him visions, right? Apparitions that come to tell him about his future. So the first apparition says, "Macbeth, Macbeth, beware Macduff. Beware the Thane of Fife, dismiss me, enough." Then the second apparition appears. This is a bloody child, which is freaky. "Be bloody, bold, and resolute, laugh to scorn. The power of man, for none of woman born shall harm Macbeth." And then Macbeth says, "Then live, Macduff, what need I fear of thee?" Okay, so the first one is saying, beware Macduff, might want to think about killing him. The second one is saying, yeah, but no one of woman born can kill you. So, and so Macbeth says, oh, all right, I don't have to worry about it, right? What he misses, of course, is that Macduff was, well, technically he did not have a normal birth. He had a cesarean birth, okay? So he was not technically a woman born. So again, the oracles are being tricky. It sets up the dramatic irony that drives the story, and nobody likes Macbeth anyway because he's a murderous traitor. But we'll forget that. But what does this have to do with our climate story? Well, I think one of the messages here is that heroes often hear what they want to hear. Okay? Macbeth wanted advice. He got advice, but there were some nugget. He didn't really grapple with the advice. He heard what he wanted to hear, and he went on his merry killing spree. So how does this play out for our heroes? Well, let's imagine a hero sitting in an office, right? He just bought a big truck. He's really excited about this weekend taking his big truck out in the woods. He's going to go drive it around through the mud. So he gets some advice, right? Carbon dioxide is making the world warmer. A warmer world is more dangerous and costly. He also is getting somebody filtering some of the advice that says, perhaps CO2 is making the world warmer, but shifting from carbon dioxide would be really expensive. So which of these is going to be more persuasive to him? Somebody who's saying, oh, I don't know, that truck was not such a great idea. You're kind of, you're not really doing a great thing for the planet with that giant truck. Somebody saying, yeah, it'll probably be okay. I suspect that many people gravitate towards those arguments because they're telling them in some ways what they want to hear. So let's think of here's another myth. This is my favorite one.
Sir, the possibility of successfully navigating an asteroid field is approximately 3,720 to 1.
Never tell me the odds.
Never tell me the odds. One of the greatest movie lines ever. Okay, now, forget for a minute that, right, C-3PO is saying, don't go into the asteroid field, you're going to kill us all. And Han says, never tell me the odds, and he goes into the asteroid field. Forget that he makes it, okay? Let's assume that C-3PO is giving really, really good advice. So sometimes heroes are bad. Sometimes heroes are lucky. Sometimes heroes have a Wookiee as their co-pilot, which is a good thing to have. Sometimes they have a Jedi sitting behind them who they don't know. That was a hard thing for 3PO to factor that one in. But heroes are really bad at evaluating risk, especially with anything involving statistics. Heroes are focused on details in the short term, okay? Especially in these action stories. Climate change is about statistics and risk, right? That's what climate is. It is a change in the statistics. It's a change in the likelihood of the weather. It's not the change in the weather. So you don't experience climate, you experience weather. You see climate if you look at the data, and that is really fundamentally challenging because people want to make decisions based on the input that's coming into their, into their eyes and ears, and climate change is not giving them that input. This difference between heroes and oracles, though, I think it goes even deeper than stories. There's a reason why these stories are so resonant, and that's because I think it taps into something that's deep in our psychology. So this guy, Daniel Kahneman, who won the Nobel Prize a few years ago for doing work on behavioral economics, poses the idea of something that sounds a lot like heroes and oracles. So heroes are what he calls system one thinking. This is our default thinking that we possess, and we've evolved over millions of years to think this way. It's a rapid matching of inputs with experience. Okay? This is the kind of thinking, the kind of psychology that lets you drive a starship through an asteroid field. One of the hallmarks of system one thinking is that you're looking for a story, right? You want, just like with Macbeth, you hear what you want to hear. You are looking for confirmation. If somebody gives you that confirmation, you're like, okay, I'm right, I'm going to move on with that decision. System two thinking is analytical and it's logical. It also requires energy, and you can put people in brain scanners and monitor their blood chemistry. You can see that when you're forcing them to go into system two mode, where they really are having to grapple with a problem, with a math problem or a word problem, that they start using more energy, okay? Which explains why system one is the default. Even people who are trained, even scientists who are trained in system two thinking, are still really reluctant to do it. You have to train yourself, just like an athlete, to want to do that kind of thinking. So, climate change, I think, is the ultimate oracle problem. It's complex, it's abstract, it's statistical. It requires a lot of system two thinking. It does not give you the input that you need for system one. To act, heroes really need that input. They need input that is simple and that's tangible. And so the question is, how do we avoid tragedy? Okay? Because, as I hope you've gotten, there is a tragedy out there that if we don't act to curtail carbon emissions, we are looking at a very different world that will be very challenging to us as a species as well as lots of other species. I think one way that we can think about this is again, thinking a little bit about that system one, system two, or heroes versus oracles. So I'm going to lay out an axis here. The axis is trust versus understanding. And I'm going to draw a curve in the middle. And if you are on this side of the curve, if you have a lot of understanding of a problem, you're going to act based on that problem. The other way you can get across that curve is if you have a little bit of understanding but a lot of trust in the message. Okay? So somehow that's signaling your system one thinking, and you're able to say, I recognize that pattern, I trust that input, I'm going to act accordingly. Our hero is stuck here in the middle. Okay? So what do we have to do to get them to act? Okay, C-3PO is giving the advice. The odds of surviving the asteroid field are 3,750 to 1. Well, one thing we could do is we could try to increase the knowledge of a hero. This is certainly something that we're trying to do here. That's going to be a big part of the new education experience that we're building here at the Cohen Center. And it's not necessarily to indoctrinate people to climate change, but it's more to help give students the ability to reason with data, to look at a data set, to read a graph, and to make decisions, to really try to activate that system two thinking. But I think it's asking a lot for the average American who has lots and lots of other things to worry about to spend time poring over global climate data and really trying to wrestle with, does the CO2 story make sense to them? So the other thing we're left with is, how do you build trust, right? How do you get somebody to trust the message? And this is really hard. And in part, if you look at some of the myths and certainly some of the ways that the climate denier community functions, one of the things they try to do is to break down trust in science overall, and in particular scientists who are talking about climate change. You think about the ClimateGate email scandal. That played right into breaking down the trust. So I think one of the things I would like to think about is, well, what if the oracle had been different? What if it had been a different character giving Han Solo that advice? What if it had been Chewie, right, his loyal sidekick? If Chewie had said, Han, don't go in there, Han wouldn't have gone in there, I think. Leia, I think as well, especially if it was something where he had a lot of trust in her. She's a natural leader. highly intelligent, especially if she gave him an order, I'm 70% of the time he'd follow it. But then I want you to think about in your daily life, who are the people that give you scientific advice that you trust and that you act on without understanding the science behind their advice? Okay, they're doctors. Yes, absolutely. I think that's a really interesting model for us to think about. How has society been shaped so that physicians, when they give you the advice, when they say, this is the condition that you have, this is the treatment that I recommend, that you might react and push back, but you're going to go home and your default mode is going to be, I think they're right. You're going to have to work really hard to overcome the trust that you have in your physician. So with that, I would like to end, and I would love to have some questions. Sir?
You remind us that we've been to 400 parts per million before CO2, but it was over a much longer period of getting there, which allowed things to adapt somewhat to it versus our recent.
Absolutely, and we were in a more adaptive mode as well. Sorry, yes. So the question was, I said that we were at 400 parts per million before, but we got there much more gradually than we are getting there and driving past right now. And you're absolutely right that the rate of change now is unprecedented, and so that creates a huge challenge. So plants are not able to move across the landscape the way that they would if we were changing more slowly. Animals in the ocean are not able to move further north, for example, at the rate in which they could if the change were slower. But we also are much less adaptive than we used to be. Living as hunter-gatherers, right, just walking around the world, finding food. It was a hard life, but it's also a very resilient life because you're just kind of moving around. And so if conditions aren't good, you just keep moving on. And we have some ability to do that, but we also have a lot of infrastructure that we are very attached to that I think constrains us. I don't want to be a hunter-gatherer. Nick?
You showed that graph where even if we shut off all or a lot of the CO2 emissions, we still have a bunch of warming baked in, and we're still looking at a somewhat pretty different world probably. So should we be doing something else to cool the planet, like engineering the system?
That's a great question. I think if we are serious about, I think the first step is really to cut emissions. So the question was really about geoengineering. So should we be thinking of solutions that would keep the planet cool, that would be essentially actively cooling the planet, in addition to dealing with carbon emissions? I think that we have to deal with carbon emissions first because that's the ultimate problem. Even if we were to do things like, and this would be so in the Star Wars analogy, the way Han gets lucky in the climate sense is that we get a lot of volcanoes. So if we got, that's the 3,750 to 1 odds, and if we went into a really active volcanic period, we got a lot of sulfur dioxide in the atmosphere. That would radiate, that would reflect a lot of light back into space, and that would cool the planet. It also would change the light that's coming in to grow crops. It was a big deal here in the early 1800s when we had a major volcano. It led to to major disruption in agriculture in the Northeast and around the world. But it also wouldn't address the ocean acidification problem. So you still would have high concentrations of CO2 in the atmosphere. That leads to highly acidic oceans. So that makes so it wouldn't, coral, for example, wouldn't necessarily benefit with a geoengineering solution. Sir?
You mentioned the strip along the equator of ocean water that warms during El Nino years. Are there engineering solutions like to bring the cold water up from the bottom to help cool the ocean?
Yeah.
Is there some idea that involves also like snowmaking?
I haven't heard one that involves snowmaking. I'm sure they're out there. I've definitely seen ones that have talked about generating artificial upwelling. You usually see that in not so much for the cooling effect, but because if you bring cold, nutrient-rich water to the surface and expose it to sunlight, you get high primary productivity, so you get a lot of photosynthesis. That can be either used by, to grow fish, or that extra productivity you could let the phytoplankton bloom decay and sink, and then you get carbon dioxide that's basically sinking to the deep sea. So you could try to accentuate the carbon cycle that way. But doing it on the scale of an El Nino would be a really remarkable engineering feat. It's many, 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 many atomic bombs worth of energy.
And is there a front on the aerial engineering, like specifically Skyborn?
Well, the one that Skyborn aerial engineering for the geoengineering, the big one is basically to mimic volcanoes. So you would just fly airplanes around, you would release sulfur dioxide in the atmosphere. Ironically, we just spent 20 or 30 years trying to reduce sulfur dioxide in the atmosphere because it caused acid rain. So it's one of these, I don't know, there's a metaphor there, devil of this and devil of that, two devils somewhere. Ma'am.
I was kind of curious. I've been having a lot of conversations recently with people about climate change, and as you say, Thanksgiving is coming. Something that I can mostly get people to agree upon is like CFCs or like DDT. There's a very discrete problem and a discrete solution. Is there anything in climate change that you would be like, this is a discrete part of it, and this is the effect that you see immediately? Like, I've been trying to.
That is so challenging. I think this is why climate change is one of the most pressing, it's one of the most difficult challenges that we as a species have had to deal with. I've heard somebody say that if you had to design a problem that humans would not be able to handle, this would be it. So here I'm being a little bit negative and cynical here tonight. I do think we can handle it, but I think it's a really big challenge, and it's going to take a lot of work. So as far as tangible things, one of the things that I think is really tough is to talk about hurricanes. So hurricanes are one of these. So we've had this record hurricane year, lots of tragedy in the news, something people are thinking about. If you look at the statistics in terms of the numbers of hurricanes, or the numbers of hurricanes above a certain category, you don't see statistical trends. Yet the physics says that a warmer ocean leads to a warmer, wetter atmosphere, which leads to more potential for big storms. So this year is very consistent with the physics. And so it's a real challenge, and there's a debate that's going on in some of the scientific community about how do you communicate about hurricanes, because there is a clear climate connection. There is a really strong case to be made in the physics. It's highly motivating for people. It is a really real connection obviously for a lot of people who experience them. But the statistics are just a little squirrely. And so somebody said that, yeah, but by the time we have enough hurricanes, because even in a really active year, you're getting 10 hurricanes, right, 12 hurricanes. The statistics on small integers are really challenging. And so by the time we actually have a long enough time series that you can get a statistically significant trend, it will be 20 or 30 years. And it will be obvious, I think, anyway. And a lot of the climate scientists are saying it's obvious. So I'm not sure I helped you, but.
I think the difference there is like you were being like, well, statistics says this and all of things, whereas like someone else, perhaps a politician, might be like, that's not related. Like the scientists are always like, well, we can do this with this, yeah.
Yeah, and I think it gets to a little bit of maybe different sort of modes of thinking among the scientific community, whether you're sort of more inspired by the theory, right, by the physical calculations you can do on heat and water vapor and the theoretical limits of how big and powerful a hurricane can be, or whether you're somebody who's like, I got to see it in the data.
Yeah, and it's like, how true is that, right? You want to tell everyone how true it is.
Right. And I think one of the mistakes scientists often make is to over-explain. So one of the sayings I've told every student who's been in my lab when you're putting together a talk is that if you're explaining, you're losing, which was something that I heard in one of the political discussions years ago, that you really want to minimize the amount of explanation you do especially when you're talking to a public audience. So hopefully I did that tonight. Yeah. Sir.
What was the role of methane? You didn't mention methane.
I didn't mention methane. Thank you. Methane is a really potent greenhouse gas. Methane is released primarily by things like by decaying organic matter if it decays in an anoxic environment. So you get that in places like swamps and bogs. You get that in the stomach of a cow. And so all of these are releasing methane. Methane is a potent greenhouse gas, but then methane decays to CO2 in the atmosphere. I forget the time frame. It's several years that it takes for that to happen. So releasing methane leads to extra warming, and then you get a residual warming that persists as that converts to CO2. The big thing that people are worried about in the climate scenarios with methane is all of the methane that is stored in sediments, and especially in the Arctic Ocean in cold areas. So you have these methane crystals that have formed in the Arctic Ocean. If the water or if the tundra gets too warm, that methane will start to bubble out, right? It will turn from solid into a gas, and then it gets into the atmosphere. And there's some geologic evidence that that's happened in the past, and that you get an extra kick in warming when that happens. So that's one of these sort of tipping points that people worry about in the climate system. Ma'am?
One of the questions I have is, we're talking about, well, you referred to our dependence on infrastructure, our safety, cozy part of our lives. And then on the other hand, we're talking about trying to convince people who don't perceive climate change the way that you do, or maybe some of us, accept it. So it seems to me that we can't spend all our energy trying to convince, but maybe with trying to change the way we live, and as an example to others.
Thank you for that. That was a really great statement. It's something that I've thought a lot about. I used to think that, yeah, if I buy a Prius, that, well, really I'm not buying as much gas, so that just means that there's less demand, so that the price just goes down, and so it makes it cheaper for my neighbor who has the Hummer to go drive around, right? And so I used to be like, well, what's the point of this? But it was actually going to listen to a church group. I'm not a particularly religious person, but actually hearing a church group talk about climate change, and they phrased it in moral terms. And they said, we have a moral responsibility. It doesn't matter what anybody else is doing. We have a personal responsibility to take care of the planet, and so that means a certain actions. And I think there's a lot that we can do to show people that, yeah, actually a low carbon future isn't a bleak future. It isn't one where the economy shrinks and we go back to living in caves. That's actually the other one.
So what are some channels that people can do to make that happen?
Well, great question. I mean, there are political discussions going on all levels of government. I mean, it is still being discussed. There's the Citizens Climate Lobby that I think is a really interesting one that is trying to build a bipartisan consensus around climate action in the Congress, and actually having some success getting a group together to do that. I'm really intrigued by what can happen at a local or at a state level. So in New England, we're part of the Regional Greenhouse Gas Initiatives, RGGI. This is the only cap and trade, one of the few cap and trade systems in the world. So we, together with Massachusetts, New Hampshire, all of the New England and Mid-Atlantic states except for New Jersey, they pulled out, are part of a consortium where we limit the carbon dioxide emissions that our power plants are allowed to produce. And so we have successively reduced the carbon dioxide from our electrical infrastructure in New England. And it's actually been a boon economically. And so I think it shows that these solutions aren't always super costly. Can I take one more? Okay, ma'am.
Yes, I want to follow up with what she said. I've been a part of 350 Maine, and we've been helping to keep I've been a part of 350 Maine. We're the people that put the big rally against the tar sands on the Maine State Pier back in 2013. And I'm frustrated and get here earlier to get you on a Facebook Live so that more people can see this. I think what she said was really brilliant. I'm sorry I didn't get here fast enough to ask you to do that first, but I really believe I've been sharing two things. And I'd like to know what you have to think about this. One is that we need to urgently establish a new clean green energy economy, one in which all working in the defense, nuclear, fossil fuel industries and the unemployed are provided positions earning more than a living wage, which goes to your, like, providing your Hummer neighbor with the, you know. And also I think that we need to find out who are supporting these fossil fuel projects, you know, like the Dakota Access Pipeline, DAPL, and the Keystone XL, and all of these types of things, and make sure to pull our money out of the banks that are supporting those and take our divest and then reinvest in these alternative energies and also into credit unions that are more responsive to the local communities. And I'd like to know what you have to say.
Yeah, so thank you. I appreciate your enthusiasm. There are a lot of strategies that are out there. I think 350 has some really good energy around a few solutions. There's some other solutions that that people are talking about. I think a really interesting one is I'm a bit of a fan of the carbon fee and dividend, where you put a price on carbon, but then everybody gets some of that money back because it softens some of the blow of the economics. I'm not an economist and I'm not a policy analyst, and so anytime you get into a policy debate, there are always trade-offs that are, I guess in this case, I'm aware of my ignorance, so I'm reluctant to really advocate for one particular solution or another. But more what I just wanted to do was I think there's a lot that needs to be done just for recognizing that there's a problem and generating some support that we should solve it. Personally, while I would love to see a low carbon future, I would, as a scientist, I would like to see the policy debate be informed by science. So I would like to see people say, we hear you, it's coming, and but maybe we're not going to do all of the carbon stuff that you want us to do, but we're going to invest seriously in making our society resilient to climate change, because at least that's a rational discussion, and I don't think we're at the point of a rational discussion politically yet. So thank you very much. Ellen, do you?
Thanks, Andy. Thanks to our sponsors, the Joan Kelly Charitable Trust and Fish Vet. And thanks to all of you for coming. We really appreciate your being here and hope that you'll tell others about these C-State lectures. They actually are live streamed, and so if you want to share it with somebody, you can go to our website and you can find it there.
And they've been recorded, so you can watch anytime. You can rewatch and binge watch.
If you didn't quite get it,
Yeah.
watch it a few times. So please tell people about it, and if you'd like to know more about GMRI, there are materials out there. We also have a monthly lunch and learn where if you're interested in hearing more about GMRI, you can go on a tour, hear a little bit about our programs, and those are on the first Thursday of every month. So those are coming up on November 2nd and December 7th. Our next Debunking Ocean Myths lecture will be on November 9th. That one will be tuna debunked, so we hope you see you back for that. And hope you'll consider supporting GMRI. We have it's a beautiful building, a beautiful lab, incredible work that's going on here, and it all takes resources. And you will find envelopes out there that are very suitable for gifts if you'd like, and/or go to our website. Again, thank you so much for coming, and thanks to Andy. Have a good night.